Welcome to a lesson with Dr. Powell. Let's take a look at the ideas of combining functions and what they mean for individual points and evaluating. Specifically, we're going to look at some graphs, but if we had tables, it would be the same basic idea. What does this mean? G, and we read this of f of 4 equals what? Well, this means that we take 4 and we plug it in. We're reading from right to left with function input, and this is like one function going into another, so it's read from right to left. We plug 4 into f, we plug that output into g, so 4 into f and then into g. So we look at the table and think, well, or the graph, and we think, how do we plug 4 into the function? We go to the x value, which is 4, we plug it in, output 3. So then we take the output of f. So it's like this. Maybe we can write this out. We could say 4 goes to 3 via f. And then where does 3 go? Via g. So let's think. We plug 3 into g and it goes up to 1. The output is 1. So that means this would be equal to 1. Okay. So let's look at the next example. We'll just work through each one of these. All right, f of g of 2. So you think we take 2 and we're plugging it into g. So reading from right to left. 2 goes into g. So 2 is the input for g and it outputs 4. So we think 2 is in G, outputs 4. Then we want to run that into F, 2 to G to F. Okay, and so what does F do to the output 4? So you put it into F and it outputs 3. Therefore, this would be 3. Remember, this circle notation means composition, so we're putting one thing into another. Okay. Following one function with another function. So then what about this one, f of f? So this means we run the function f, then we run the function f again. So we start with 4 and we run it through f. Let's see what we get. 4 run through f, output 3. Okay, we output 3. Then what are we gonna, we're gonna put 3 now into f again. So 3 goes as an input into f and it comes up and it outputs 2. Therefore, this would be 2. Okay, let's take a look at another. All right. What about over here? Okay, now this, oh, wait a minute. Let's do this one. I didn't do that one. G of f of 6. So first we put 6 into f. So 6 goes into f and it outputs 0. So 6 outputs 0 by f. And then what does it do to get to, then what does 0 do in g? So we put 0 into g and we output 6. Well, that's kind of handy. So we put in 6, we got out 6 for that one. So we put in 6 into f and then we output 0, put the 0 into g, output 6. Okay. Now, next, let's take a look at a few more. All right, what about f plus g of 1? What is that equal to? Well, now what does this mean? This means to take the output of f at 1 and the output of g at 1 and you add them together. So really, the 1 is actually going into both f and g. The only time it only goes to one of them is when you have a circle here for composition or of. Now, when you have anything else like plus, subtract, times, or divide, then this input actually goes to each of these. So in this case, we just plug 1 into each of them. That one might be a little simpler because we know we're just doing the same thing in each graph, same input. So for the G graph, we say 1 goes into G and it outputs 5. In fact, if we want to, as this is written, what we can do is just right above the letter signifying the function, we can just write out the output. So 1 goes into G and it outputs 5. So I can write a little 5 right here. Okay, now 1 goes into F. So let's see, 1 goes into F and it outputs 2. So I can write 2 right above that F. Then I can think 2 plus 5 is 7. That's it. That's all it is. Okay, let's go. It's just notation and getting used to what the notation means. All right. What about this one? F minus G. So of 4. So we're putting 4 into both G and F. So 4 goes into G. It outputs 3. So think 3. And then let's see, 4 goes into F. So 4 goes into F and outputs 3 as well. So it looks like, let's see, so let's make sure G, yeah, so it looks like it outputted 3 for both of them. So 3 minus 3 is just 0. Okay, let's go to the next one. 2, so we're plugging, so since this is times and not circle, we're gonna just plug the 2 into both of them. So here we take 2, goes into G and outputs 4. 2 goes into F and outputs 2. So we have 2 times 4 is 8. Okay, now we go to the next one. All right, so 3 is going to G and 3 is going into F. So we think 3 goes into G and outputs a 1. Maybe we'll write it off to the side this time, 1 divided by, and then we see what 3 does with F. So 3 goes into F and outputs 2. All right. Aha, it's just 1/2. So that's a little description of combinations of functions and how to think about them point-wise, especially if we have things represented in a graph. But both of these graphs may as well have been represented in a table as well. Thanks for watching.